Today we have a bunch of steel parts, cold roll, very good cut, some minor issues on the smaller holes, but probably nothing too bad. We are going to run on a combination machine. You see here we have some dross. There are only two stainless steel parts. They are very, very clean. You see there is hardly any dross on these edges here. And it goes from 16 gauge through 11 gauge, that's probably 10 gauge, 11 gauge, 3/16 or 7 gauge, to 5/16, and then we have here 3/8 inch. And you see, especially the 3/8 inch is very, very, very nice and clean. We are going to do this on the combination machine, but even though it is a combination machine, we will really not use a white belt other than for a few demo parts maybe, because I think this can all be resolved on our cross belts, where you have two in the machine, one in the front, one in the back. But what we are putting on there is our purple ceramic 60 grit. Now, these are brand new blocks because we just took the machine into commission. And they have a tendency to be aggressive when it comes to burr, but not probably give you the ideal round radius edge in the very beginning until they are broken in. Then they get to be very good actually. So we need to make a small adjustment for that. It takes about 1 to 2 hours to break a set of belts in. Okay. Quickly about the controls of the machine. You have your on-off for the white belt, speed control. You have your on-off for the cross belt, speed control. You have your on-off for the conveyor belt, speed control. Okay. We have a blinking red light, which means we are in service mode. We can run with the door open if you need to, so we can see it. And this sets your material thickness, and this wheel sets your pressure. So we are going to start with a 3/8 inch part, and we are just going to use the cross belts. To set the material thickness, we are simply going to bring this here to 9.5, and that's already it, done, finished. So all we have to do is we're going to do our conveyor belt speed. We're going to go about 3 feet a minute. We're going to go slow, and with the cross belts we're going to go full speed, and we are only going to turn on the cross belts and the conveyor belt. This is the non-burr side, and this is the burr side. You can see even now the whole way. I should run this so that edge is open, then we get a better rounding on all the edges. So, here of course it's going to take a little bit longer for the part to pass through, and ultimately, if you need a cross belt only machine, the entire depth of the machine would be much shorter because you don't have the first cross belt section. And it takes a moment for the part to arrive. If you only run one part, of course, then maybe trying your patience. But if you look at this, at 3 feet per minute, you probably can run 6 parts side by side, and they are going to go in under a minute. Here you can see how the first one is. You are getting from those cross belts, right? And what you're looking for a little bit of temperature in the part, right? Nice and warm, but not hot. And you see the white line around the part, and that is your range. So, you can see, and then on the non-burr side, of course, we could go a lot quicker because we don't have any burrs. So let's go about 4 feet a minute. So this is about 4 feet a minute. I will write all this onto the surface of those parts, how we run them. This is just a demo for you to see. Now we are going to repeat that exercise for the 5/8 part. So all we have to do is we're going to reduce our material thickness. Okay? And then we can already enter this part. I'm going to run the non-burr side first. Accelerate that a little bit and then bring it back down. That will make that first step where it goes by the white belt a little bit quicker. That comes out nice and clean. So I'm only going to run one each. And the reason why it is lighter is because I think we've been running a little bit faster. So, and now we are going to do the burr side again. We are going to accelerate that, but then we are going to slow down to about 3 feet a minute. But it is not necessarily the best surface for painting. If you did that in combination with a white belt, of course, it would be much better. So, and now we are going to run one of these small parts. And here you will see that you have some of the dross that a cross belt may not be able to remove. And because it is a small part, first of all, we need a backup here. We are going to back up about 1.5 thou. About 1.5 millimeters. And this is about 3.2 millimeters thick. There we go. Now, just clamp that onto the conveyor belt, high friction conveyor belt. If you need more friction, then now we're also going about 4 feet a minute. If you need more friction, then you need to clean the conveyor belt. Very simple household cleaner. Coming out, straight edge. Here at the hole, you can see that that weld flash is not removed. If you need to remove that, you would have to apply the white weld. And that's what we will always do with the second part that we are running here. Okay? So I'm going to spare myself the back side because that is not so interesting. Instead of it, we are going to go to the stainless here. And again, this is the bird side of the stainless. It is a tad thinner, so I'm just going to bring that down to 3.0. Actually, I think it was 2.9. And not that that is super critical. It's a brushing machine. It's not a white belt standard you need to worry about. But if you know what your material thickness accurately is, just do yourself a favor and set it accordingly. That gives you more consistency in the process. Here we go. You see it's stainless, super nice edges, everything is smooth. Round, there's no sharpness left. Nice radius on the edge. Okay. And then what we will do with the other stainless part, I will demonstrate to you how you make a grate. Now let's run the flanges here. These were 3/16 or 7 gauge, which is the equivalent of 4.5. The table goes up for thinner material, it goes down for thicker material, and this one I'm going to run a little bit slower again. So, and you notice, of course, when the table has to go up for thinner material, it's a little bit harder for me to turn my hand than if you need to, if you're going from thinner to thicker material, where it's a little bit easier when you remove the hand. So, here we see this coming out, right? And again, you have the white line for the radius. So, this is it. Now we are moving on to this material, which is, I think we ran that almost a little hard if I ran that at 3.2, because this here was actually the 3.2. I'm not sure. This was a tad thicker than that. This was more like 4.5 before, right? Which makes this almost, I believe this was 1/4 inch. And that would be why this has been running a little bit harder. So anyway, we're going to set the machine to 3. Like I say, up is always a little harder with one hand. And I went up first a little bit, and I want to be slightly in the tail. That's my number. And this is, again, is the bird side. And this is the non-bird side. And we're going to accelerate that a little bit at the beginning. And then it at about 3 feet a minute. All the way around. On this one, I'm also going to go on the other side. Accelerate it a little bit. And then slow it down. And here I'm going to go really slow. I'm going to go only about 2 feet a minute. Just so that you can see in thinner material, it can also be a very, very, very round edge if you give it time. Then you just need to go slower so that you have more interaction between the brush block and the brush block and the part itself. See now the conveyor is really moving very, very slowly. There we go. But at that pace, you would still run, if you think about these parts disappear about every 10 seconds, you would be running 1, 2, 3, 4, 5, 6, 7, 8 parts times roughly 48 parts per side per minute on a smaller part like this. This is very, very rapid. So this again is a non-burst side, and you can see that you have a larger radius here than you have here. So now interesting, we're going to go to the 60 gauge material, 1.5 millimeter, and you have an engraving here, and you probably want to see what it does with that engraving, and at the same time you want to see how it heats up the surface. So let's do the surface here first. For that, because it is thinner, we're going to back up the brushes, and then we can go down to 1.5. Here we go. Yep. This up the ball, and then go slow. Now we're going about 4 feet a minute. You see the surface corrosion is gone. Even though you can still almost see the number that you marked down in, you can still read that. We have a well-rounded edge. And then we are going to do the same thing from the non-burr side and see that we can maintain our edging. And for the edging, of course, it is good that we are going a little bit faster. Actually, I slowed it down a little bit more to make it a better test. At 3 feet a minute, you see how we are going to affect the engraving. There we go. You can see that your engraving is still. Sorry, I just turned my camera off. The engraving is still fully here. You can read it. It actually brings it out. Okay. Now I'm going to set the machine. We are going to set the machine again for the 3/8 material. And but now we are going to run the parts with a white belt so that you can see the difference between the two. So we took the part underneath the white belt and we took a very quick scratch test to see that we are even and that we have a sufficient width of the belt on the material, but at the same time that we are not too heavy into it and that we are not crashing the conveyor belt. Now, if we run with a white belt, because we need to still run slow for edge rounding, we're going to slow that white belt down quite a bit. Again, the cross brushes full speed. And with the conveyor, we can go a little bit quicker because with the white belt, we are already removing some of the dross, so it is easier to make the radius. And I don't know if you can hear the white belt engaging with the material. So you see we have that sitting at around, this represents about 4 feet a minute. So now you see a little bit more debris coming out where we remove material from the surface. And you can see the crosshatch between the white belt and the cross belt. That, of course, is very, very, very painful surface. That will make excellent paint adhesion on the surface. And then we will do the same thing for the non-versatile. And the part doesn't get too hot. Why does it not get too hot? Because we have turned our white belt down. We just need to remove. We don't need to make a perfect surface brush finish. What we need to do is we just need to remove the dross and scratch the surface a little bit so that the surface doesn't close up. How much raw material we are removing once we are engaging the white belt. Okay, and we are going to do the same thing for this part. 7.5, 7.4. And even with the white belt, we're going to run the material diagonal because then you get better interaction between the cross belt and the brushes. And I could hear it was a little bit heavier grind. Maybe the material was a little bit more than 7.4. And with the white belt, 1 or 2 tenths of a millimeter, 4 to 8 thousandths, will make a difference. And you can see that the surface is now nice and homogeneous, but here you have pits in your surface, and of course it doesn't go deep enough to remove those pits. Okay, and we will do the same thing for this material, which I believe this was a 3/16, 4.5. And we need to see if we can remove this with the white belt. This, of course, is a very small part for the white belt, so you need to be careful that you set the machine correctly here. And actually, because this is a small part, beauty of the high friction belt is you can hold fairly small parts still reliable, parallel underneath the belt. Actually, for the small part, I need to relieve this a little bit, because otherwise we'll have too much lateral force and the pipe will not come out and will be pushed to the side. There we are. There we go. Now, of course, the surface is clean and you have your edge on top of it. You may not have quite as much of an edge because with a white belt you make it first sharper and then you have to round that again. So here you see the difference between cross belt only and wide belt plus cross belt. If you want to remove these parts by hand before, you can do that. Then, like I say, you would only need a cross belt machine. So here we go for our flange part now, which is a 6.2, 6.3. So, now, when you use this, when you use a white belt on something like this, of course you're going to remove it. So, there would be no point in this, right? Anyhow, what I wanted to demonstrate to you now is a cross head and a parallel head on this stainless steel. And for this, so this was, I believe it was 3, a little bit under, 2.9 maybe. So, we are going to run one pass fairly quickly. No, we're going to run the first part just normal at a diagonal. I will take my zoom in out, go back to normal 0.8. So here we come out, and you can see that this cross belt and edge rounding, very nice edge, super nice edge. Now on this side, I want to demonstrate something different. And what we're going to do for right now is we are going to take the cross belts out of the equation. Just going to put that up. And we are going to run fairly fast. Just on the white belt. Remember, that's the non-burr side. And we're going to run nice and lengthwise. Notice that I went over to the side. Why did I do that? Because I know that my abrasive is better on the side. See, now you have a real nice grain from the cross belt, but you also have super sharp edges because you just surface round that part. Now, what we need to do is we need to bring the cross belts back to where they would engage, about right here. But we not only need to turn the white belt off, we also have to take it out of the way. And I will show you how you do that here. You see this arrow? Basically that makes the pressure of the grinding belt. As that arrow goes up, it takes the grinding belt further up where it is out of the way. Yeah? So we just moved it about 1.5 millimeters out of the way. So even if you turned it on, it wouldn't touch at this point. Okay? And now we are going to take this part and we are going parallel to the grain. Okay? We are just going to run it through the cross belts. And in the beginning we can do it very fast. Now, this is going to give us some edge rounding, but at the same time, it's like scratch riding the surface and enhancing the finish. And now you have a wonderful, very, very beautiful brush finish on that surface, which is also smooth, because it was like if you scotch fried it, right? Of course, for this, the part has to be shorter than the machine is wide, otherwise you cannot do that. And at the same time, the edges are nice, round and broken, nothing is sharp anymore. It's a very pleasant part. And between here and here. And this is a surface just with the cross belt, and this is the surface with the white belt and the cross belt. And no worries, like I say, I will mark this all up for you. And I will run the reverse sides. I haven't run all the sides in the videos. I will run everything out afterwards. So, and now I will demonstrate to you what you probably should not do. But for that, I need to set my white belt down again. So, you see, that's also relatively quick. And that's, by the way, where you adjust your grinding pressure with the white belt according to how thick your abrasive is, what you're using, and how worn it is. So, we're going to move this up a little bit. And we're going to carefully bring this down to 1.5. Making sure that we don't overshoot. I'm going to increase the speed a little bit. And I'm going to run lengthwise. Now remember, this is where you have your engraving. And if the engraving is deep enough, you will still see it, but chances are that you are removing it. Yeah? Oh. And this is why you should never use a white belt if you have an engraved part, because it removes material evenly from the surface, but it does not give you a, so you cannot run PVC coated, or you cannot run an engraved piece. It's basically a marked piece through there without losing that engraving. That is what the cross belt only is for. And then we can run the other side here real quick at the same pace. Yeah, and that pretty much concludes our business for this video. I'll pack up all these parts, send them back to you.